How's it going, everybody? In this section, we're going to get into our VPN section of our route series. This is the most unknown and least common topic that I find that people don't understand inside of the enterprise environments. And enterprise, quote unquote, the term enterprise, quote unquote, is, in my opinion, kind of construed, because when I walk into an environment, either you know what a GRE tunnel is or you don't. And GRE tunnels are going to be kind of the focus of where we're going to spend the majority of our time for both GRE tunneling itself, understanding what DMVPN is, and then when we get into easy virtual networking, which, ironically enough, EVN, as we're going to coin it, is actually a macro syntactical improvement for VRF Lite. So when we actually get into it, I will show you guys exactly what that means and how it actually works. But the general idea is when you have EVN configured, you are trying to make things easy. So we'll see exactly how that comes into play later on when we get into that particular section of our training. But GRE tunneling, or generic routing encapsulation. Now, what exactly is that and how does it work? Well, at the end of the day, it's actually really, really simple. A GRE tunnel is a generic routing encapsulation. I know it's what GRE stands for, but it really is what it handles. So the idea behind GRE is you can pretty much put anything inside of it and it'll forward it. That could be IPv4, IPv6, CLNS. It could be IPX. It could be SPX. It could be AppleTalk. I mean, it could be literally any type of encapsulation you're dealing with in your day-to-day environment. Now, the idea behind GRE tunnels is to be able to tunnel something over something else. So, for instance, maybe you have two IPv6 islands. So you have a network of IPv6 here and a network of IPv6 over here. And in between these two islands, you have an IPv4 middle ground. Well, let's say, for instance, you need to be able to get your IPv6 traffic from here to here. How hard would that be to do? Well, with GRE tunneling, it's very, very simple. You could simply configure the GRE tunnel, tell it to be IPv6 enabled, and then you could point your traffic towards that. Pretty simple, right? Well, in most cases it is. The key thing for people to understand about GRE tunneling is it solves issues in your environment depending on how you're doing things. The reason why it makes it look like it solves tunnels, and the idea behind a GRE tunnel, is you're going to make things look like they're one hop away. Because that's what a tunnel is. You configure its source, you configure a destination, you give it a subnet, you advertise that, or you point traffic towards it. So, for instance, if you want to do a static route to the GRE tunnel, that's literally all you have to do. You configure the traffic in the static route. You would configure what you want to reach, how much of it you want to reach, or I should say, the route you want to get to, how much of it you want to get to, and then how you're going to get there. And you would point it to tunnel 0 or whatever tunnel you want to create, and then away you go. That's pretty much all there really is to it. So when we actually get into GRE tunneling, there's more to it than just that. And when we get into it, it's actually kind of cool when you start digging into the details. For instance, you could run DMVPN with GRE. And that's actually how we're going to be covering that in a few videos from now. But a couple of things that I wanted to cover before I actually get into the meat and potatoes of our series here for this section is that when you're dealing with tunnels, you are trying to get something somewhere to make it look like it's closer than it really is. GRE tunnels are where we're going to start first. Then we're going to take a look at an Ipsec Unicast tunnel. Now, what's an Ipsec Unicast tunnel? You may have heard of Ipsec LAN-to-LAN tunnels. Well, the idea behind an Ipsec LAN-to-LAN tunnel is that you are trying to connect two different networks together over a secure connection. That secure connection could be a GRE encapsulated Ipsec tunnel. And you're like, what? Commonly referred to as GRE over Ipsec, where you actually run GRE inside of Ipsec so that everything that's encapsulated is encapsulated inside of Ipsec, so it's secure. This is the only way you can run a multi-point, or I'm sorry, this is the only way you could run a dynamic routing protocol over an IPsec tunnel. And you might ask, well, why is that? The reason for that is because IPsec itself is a unicast tunnel. Now you can run your dynamic routing protocols via unicast over IPsec and it would work just fine. Now, if you want to keep the dynamic part of a dynamic routing protocol dynamic, then you would need to make sure you place it inside of a multi-point GRE or a GRE tunnel. I say multi-point GRE because when you get into DMVPN, that's what you're going to be using as multi-point GRE or tunnel mode GRE multi-point. That's going to be the actual syntax line you're going to put at the tunnel interface level. That's generally how you would get things done. So the idea behind a GRE tunnel at the end of the day is to be able to route dynamically over your infrastructure. Now, I've set this up in several different environments to solve different types of issues. Just recently, there was a company that I worked directly for, and we ended up having to run GRE tunnels over our core. And so we had a Cisco switch sitting at our edge down in customer service, if you will. And customer service had its own dedicated stack of switches because we had so many users connected to it. We connected those switches and they connected up to our core. So it was actually a 3750 at the access layer, and then for our distribution layer was a 6509, and then our core was a 6513. And the 6513 was actually labeled core. Our distribution was actually 6513 server, I think, because we had a bunch of servers attached to it. And so actually a lot of the servers had been decommissioned and virtualized. So the actual physical machines had been decommissioned and had been virtualized into our ESXi environment. So the idea behind the tunnel was to take traffic coming from the customer service phone system and tunnel it over our other devices inside in our core and drop it off at a Cisco switch that's sitting upstairs that was actually connected to a separate, a dedicated cable connection for a phone system. And so we tunneled it over our traffic, and as long as you've got reachability from where the tunnel source to the tunnel destination, then you're usually in pretty good shape. That's exactly what we did. And so I just policy routed anything coming from this particular subnet to the tunnel. It hit the tunnel, went over the tunnel, which made it look, when it was in the tunnel, the traffic made the traffic look like it was only one hop away. So then when it would get to the other end of the tunnel, on the upstairs switch, tunnel traffic would come off. We had a policy route in place to where we would policy route our traffic out towards the internet because we had two different connections. And you might ask, well, why didn't I just have a default route set up with a particular subnet? And the reason for that is because I thought it would be easier to have a policy route in place and to route traffic that way. That gives you an example of how a GRE tunnel might come into play. And there's a question, you can policy route with a GRE tunnel. Absolutely you can policy route to a GRE tunnel. You can policy route to anything. The key factor with policy routing or PBR is the fact that you are routing based off of where the traffic is coming from. So you're saying, okay, traffic is coming from XYZ subnet, and I want to point it out this direction. So the idea behind that is you're taking traffic that's coming from here, it hits this device right here, and then it goes straight up to the internet. So it's a great way to traffic engineer your routes without having to. It gives you that flexibility because if you, unlike a default route or a static route, it's destination based with a default route or a static route, where policy routing is source based. So it gives you that granularity. So what we're going to take a look at in this video is going to be GRE tunneling in its basic form. So what we're going to do is we're going to form GRE tunnels over from router 5 down to router 11 and 12, and that's going to give us an idea of how this was actually going to work. Now, the whole premise behind this entire setup that we've got going on here was to make sure that when we were going from traffic from point A to point B, when I was setting up OSPF and frame relay and BGP and all those other protocols that we've already covered, the whole underlying process to that was so we could get GRE tunneling going here. So we're going to get GRE tunnels configured. I'm going to show you guys how to route traffic over it, and it's actually relatively straightforward. Now there's a question, policy-based routing is a band-aid, quote unquote. That's a good way to put it. I would definitely say it's definitely policy routing is used to fix issues so that you can come back to get quite frankly, the only time I've ever used policy routing is to fix an issue until I had a better understanding of what to do later on. So let's say something's broken, you want to make a change, get it operational again. Maybe you had a change and then it broke something else, or you found that something you had configured was working fine, and then you made a change on a firewall, and then now the traffic is no longer able to go through the firewall, so you need a policy route it elsewhere. Those are different situations. So different situations or different scenarios call for different tactical solutions. So, and I put it in those terms because that's usually what they are. They are situational-based tactical responses to a situation that you might be incurring. So, for instance, your phones no longer have internet connection, and they're SIP-based. So they need to have an internet connection in order to get out to actually function. Well, you would use a policy route to get it to where it's got to go. So that's usually how you would do stuff like that. So what we're going to do is we're going to take a look at the actual details to policy routing, and I'll go for it. And actually, really, policy route GRE tunneling is really, really simple because of what it gives you the ability to do. And what we're going to do is we're going to take a look at a GRE tunnel, and we're going to tunnel this traffic from here to here, and from here to here. We're going to have two different tunnels. Tunnel 1, or we'll say tunnel 115, and tunnel 125. And the reason for the different numbers is so we can see how things are going to work. We're going to start out with a static tunnel, so you guys can see how that would work. And then what we're going to do is we're going to move into Ipsec. And because I think once you guys understand how the standard or standalone configuration with a standalone tunnel, a standalone Ipsec connection, is when you start to understand how that stuff works, then it'll make more sense down the road. So the idea behind here is I'm going to have the tunnel's number, the tunnel IP addresses are going to be 10.100.115, or 115 and 125. That's going to be what I configure it as. This will give us that flexibility to play with different capabilities. So we're going to configure the GRE tunnels first in this video. Then I'll cover Ipsec. Now I'm not going to get into anything really weird with Ipsec. It's just going to be a standard Ipsec tunnel. And then what we're going to do, actually in the next video what we're going to do, is once we have the Ipsec tunnel configured, then we're going to be able to go in and set it up so that we can say where traffic is coming from, where it's going to. So you can see this the standalone static configuration. And then we'll move into DMVPN. We'll talk about that, get it operational so you guys can see how that would work. And then once we have that situated, that pretty much ties in what DMVPN does. And then from there we'll get into EVN with Easy Virtual Networking and show you guys how that works and how it's different than DMVPN, so there's really no correlation. It's much closer to VRF Lite, and we'll talk about how you would manipulate that as we're going through. So now, usually when you're dealing with tunneling with GRE, just some of the specifics to it is protocol number 47. So if you happen to see protocol number 47 pop up anywhere, that's an indication to you that is a GRE tunnel. That's its IP protocol number. If you see 50, that's ESP. That is going to be your phase 2 tunnel in Ipsec. If you see ISACAMP, that's going to be phase 1 Ipsec. Or I should say, Ipsec and ISACAMP are actually two different ways of configuring a tunnel. ISACAMP is going to be your router-to-router configuration, and Ipsec is going to be the LAN-to-LAN. So you need to have your routers talk to each other first. So this is where GRE kind of comes into play. GRE is going to come into play, and a standard GRE tunnel is going to look something like this. We're going to bring up our configuration here, and we're going to go to router 5. I'm going to go to global config, and we're going to type in interface tunnel 115, or tunnel 115. And we're going to type in it. We have a couple of options here. Now there's not a, I mean, it gives you quite a bit of capabilities here, but what we're going to do is type in tunnel question mark is going to be source, and we're going to source it off of our outside interface. Now why the outside? Well, the reason why we're going to do our outside interface is because of the fact that that's where the remote side knows how to get to. Now technically speaking, I could go in, excuse me, and I could specify the loopback if I wanted to. Now, if it's going to be a LAN-based Gre tunnel, where you're trying to tunnel something over the LAN, and both devices know how to reach each other's loopbacks, then that's fine. But the minute you go over the internet for any type of internet reachability, you want to point the source traffic off the outside interface, so that the internet-facing interface, so that the remote side knows how to get to it. Because if the remote side can't recurse to it, the tunnel will never come up. So I'm going to type tunnel source is going to be, what do I have here? Do show IP interface brief. 155.0.0.2. So tunnel source is going to be, I can either type in the IP address of 155.0.0.2. That would work. Now the tunnel destination is going to be, 115.0.0.2. Okay. Now the main thing that you want to do here is you want to make sure, and notice how it came up here. So the tunnel 115 is changed to up. We're going to type in do ping 115.0.0.2. Well, fortunately for us, we can ping it. We can reach it. That's a good sign. So what I'm going to do is I'm going to go in here. I'm going to type an IP address. Is going to be 10.100.115.5/24. That's all I have to do. Okay. Now what I'm going to do is I'm going to go, and I'm not going to yet advertise it into OSPF. I'm going to go over to router 11. I'm going to type in interface tunnel 115, and I'm going to say, now see how it's changed to down. Now, if I typed in tunnel source of 115.0.0.2, it's not going to change anything. If I type in tunnel destination and typed in 155.0.0.2, that will bring it up, because now it knows how to get to where it needs to go. The same thing would happen if you were to type in tunnel mode Gre multipoint. You have to tell it, you have to give it a compatible capability. So we had that in place. Now I type an IP address of 10.100.115.11/24. Now the tunnel is up. Now here's the key thing. Can we ping it? So do ping 10.100.115.5. That's a great sign. Now, what does that tell us? Now, do trace to 10.100.115.5. It's directly connected. Now, how can we reach that? Well, the reason we can reach that is because of the fact that we have reachability to it outside of the tunnel. If you don't have reachability outside of the tunnel to the tunnel destination, it's going to be you're going to have a hard time getting to where you need to go. So that's the tunnel. Now, the one thing you don't want to do, and you get into recursion issues, is you do not want to have the tunnel learn itself. The tunnel's destination must not recurse to the tunnel itself. Now, what do you mean by tunnel destination? Tunnel destination is where it's going. So if I was to advertise this link right here, if I was to redistribute that, so if the tunnel was to learn 155.0.0.2 through the tunnel, then it would recurse to its down, because then it would just be looping. You don't want things to loop. So the idea here is to use either filter out the tunnel destination, or make sure that the tunnel is not going to learn its destination through itself. Because remember, if you're going to get to 1, 2, 3, 4 via the tunnel, and then it's tunnel via 1, 2, 3, 4, it's going to recurse to itself. So by typing in do show IP route, you'll see the tunnel 115 sits here, and it's reachable. And if we look at do show IP route for 155.0.0.2, we're reaching that not by the tunnel but by BGP. That's how we're able to get, that's how we're not recursing to it. So at the end of the day, it's still directly connected to us. If we went in and we typed in shutdown on the tunnel, right? Let's shut down the tunnel. Alright, tunnel's down. Now do trace to 155.0.0.2. We can still get there. But the tunnel makes it look like it's one hop away. So we type in no shut here. We're good to go. Now, here's the thing. We're running OSPF on this side of the network, right? So do show run pipe section OSPF. Give that a second for it to load. We can advertise this guy in. Actually, 11's not running OSPF? Do show IP protocol. Oh, okay. Thought I was running OSPF. Oh, okay. Alright. Never mind, sorry. Had a freak out moment there for a second. Do show IP interface brief. So we have these links, we have these connections in here. We want to advertise them into OSPF. Not the 115 network, but the 10.255 and stuff like that. So we're going to go to router 5 and type in do show IP interface brief. And we have the 10 network. So we're going to type in router OSPF 5 and type in network of 10.100.115.0 over area 100. Okay, and that's going to let us know that it's going to be an inter-area route. Area, oh, sorry. 0.0.0.255. Okay, now what we're going to do is we're going to go to router 11 and do the exact same thing. So router OSPF 11 network of 10.100.1115.0 0.0.0.255 area is 100. We formed an adjacency over the tunnel. That's great. That's a good sign. Now, if we do a jump out here and do a trace route, or to do a show IP route, we're going to see a bunch of routes come in via, let's see here. Some things are coming in via tunnel 0. Everything else is coming in via BGP, that's fine. That's completely okay. So what we're going to do is we're going to do a trace route to 10.1.5.5. So we're going to do a trace route to 10.1.5.5. We're going to go over the tunnel, and how do we know it went over the tunnel? Because of the address. It went over to router 5, dropped off at router 4, and then dropped off to router 1. So that's how that goes. Now the thing is, what if you don't have what if you want to make something a little more direct? So let's take a look at this. We have a route to, via BGP, to, let's see here, to router 1, right? So we could create a tunnel directly to router 1, right? Well, do you want to do that? You absolutely could if you wanted to. So that's one capability you have. But what happens if you need to do a tunnel from a spoke site to a core site? Well, we're kind of already doing that. So the benefit to having a GRE tunnel is you have the ability to make traffic look like it's one hop away. That's going to be a technically speaking, it's actually a worst forwarding metric because of the fact that the GRE tunnel is going to have a slower bandwidth and a higher delay, so it's going to be less desirable from a routing perspective, but it gives you that flexibility to add traffic in if you want to. So the main thing that I want you guys to take away from this is GRE tunneling is a way for you to change how you're going to forward traffic. So like for instance, if I wanted to go to router 1 and type in interface tunnel 100 and type in tunnel destination is going to be 115.0.0.2 and type in now it's going to, and tunnel source is going to be my loopback 0. As long as router 11 knows how to get there, so do show IP route, as long as router 1 knows how to reach 115.0.0, that route right there, the one that I just highlighted, as long as he knows how to reach it, that's going to be the main thing. So do ping 115.0.0.2, he knows how to reach it. Now if I went back and I typed in IP address of 150.0.0.1/24, and then I went over to router 11 and went in global config and typed in interface tunnel 100. Tunnel source is my loopback 0. And as long as router 1 knows how to reach router 11's loopback, actually, let me do this. Let me source it off of the. Let me source it off of serial 2/0. And tunnel destination is going to be. We have to point out to, and since we know about router 1's loopback, that's going to save us some time. We're going to type is going to be 10.255.1.1. Right, so the tunnel's up. Do an IP address of 150.1.0.0.11/24, and do ping 150.0.0.1. We can ping across it. Then we would type in IP OSPF 11 area 100, and the same thing with 5, and type in router 1. Typed in IP OSPF 123. That is a do show IP protocol summary. Yes, IP OSPF 123 area. Area was it area? Did I type in area 100? I did. Area 100. That's going to bring the adjacency up. And that's going to, now if we wanted to do a trace, now we went back to 11 and we typed in do show IP route, we're going to see that we're learning 155, let's see, 115, 100, tunnel 100, let's see here, let me go into interface tunnel 115 and shut it down. That'll help, that'll clean some stuff up here. We should learn stuff through tunnel 100. So there we go. So now we're learning this route. So the 100, 100, 100, 100. So we did a trace route to, do trace to 100.100.100.100. We're going to trace directly over the tunnel. Even though from a physical standpoint, we're routing this way, up towards router 5. We're hitting all this, and then we're getting to where we need to go. It's one physical hop away. That's where Gre Tunneling comes into play. So it makes it look like it's one hop away. The drawback to it is lower bandwidth, higher delay. So those are things you want to take into consideration when you're going through and getting your configuration set up. But that's basically how you could have a backup route, or you could use backup interfaces with Gre. I mean, there's a lot you can do with Gre. It's just to give you an idea of how it would actually work. So that's the general idea to it. Just be careful when you're dealing with it, because if you are going to reach the destination through the tunnel, that's a bad sign. So what I'm going to do is I'm going to go back to our configuration window over here, and I'm going to type in. I'm going to say no interface tunnel 100, and I'm going to type in interface tunnel 115 no shut. I'm going to do the same thing on router 1. I'm going to type in no interface tunnel 100. That'll take that down, bring router 5 back up. So router 5 is done again. So we're good to go there. So the main thing that I want you guys to understand is, as we go through here, it'll be relatively straightforward to get things done. But I'm actually going to take the tunnel down. And I'm not going to create that other tunnel like I said I was. I wanted to show you just a couple of different tunnels. The reason why I'm going to shut these tunnels down, so I'm going to type in no no interface tunnel 115. The reason I'm taking these down is because of the fact no interface tunnel 115 is because when we get into when we get into DMVPN, that will be a separate tunnel on itself, and I will create another tunnel just so you guys can see it over and over again a couple of times. So the general idea is going to be able to, when we get the next video, I'm going to show you IPsec. I'm going to configure IPsec and show you guys how that works, and then from there we'll route it over GRE, and I'll show you a couple of the different tweaks you have to make in order to get that to work. And then from there, it's relatively straightforward to get operational. And then I'll bring in DMVPN, because I think that will bring everything in for you, so you guys can see the configuration simplification of DMVPN over doing a static GRE tunnel, a static IPsec, and then having to do all your routing. It makes things a lot simpler. So that's pretty much it for GRE. I hope this has been informative for you. I'd like to thank you for reviewing.